Good day, Mamadi. Good day, everyone. We are here to have our final oral presentation. Our technical report is about the welded plate heat exchangers, and the researchers are Carlo Feliciano Pasno, Daniel Joseph Sanchez, Philip Alexis de Jesus, Rainmark Ambrosio, Prince Jonas Canlas, John Punsalan, Mark Paul Angel, Helson Cruz, and we are Pasno et al. For the overview, millions of scientific discoveries made from different parts of the world were in fact shed light for people to embrace a new concept of society where everything is almost accessible, efficient, and can be done easily. With so much exploration coming out every year, it is easy to perceive that lives on Earth positively change little by little. Including to these discoveries had created are the machineries, which seemingly rule everyone's life at present as they function better than what human beings can perform. Take the refrigerator for instance. This makes it simpler to eliminate contamination of food with bacteria, especially with meats. However, some of these machines require a regulation on their systems relating to temperature in order to work well or improve more what they can do. It is where heat exchangers come into play. Heat exchangers are agents formulated to transfer heat between two or more fluids of different temperatures. Depending on the type of heat exchanger employed, the heat transferring process can be gas to gas, liquid to gas, or liquid to liquid and occur through a solid separator, which prevents mixing of the fluids. These are primarily used in many engineering applications, such as refrigeration, power plants, and many more, as it serves not just a temperature panel, but also a sentinel when having a downtime. Moreover, heat exchangers appear in different configurations as well, depending on the need of a subject matter. In particular, the plate fin heat exchangers, shell and tube heat exchangers, double pipe heat exchangers, spiral tube heat exchangers, gusset plate heat exchangers, and etc., and also the welded plate heat exchangers. For the introduction, the welded plate heat exchanger is one of the plate heat exchanger types discovered by Dr. Richard Seligman in the early 1900s along with gusset, semi-welded, and brazed plate heat exchangers. It is made of a series of corrugated metal plates, welded by laser or argon arc welding. The plate groups are connected by welding with molding strips. Because there is no gusset seal, it has higher temperature and pressure resistance. Hence, it can be applied to extreme working conditions of high temperature and high pressure. In addition, fully welded plate heat exchangers are further divided into non-detachable fully welded plate heat exchangers, two-sided detachable fully welded plate heat exchangers, four-sided detachable fully welded plate heat exchangers, and wide-channel fully welded plate heat exchangers. This specific type of plate heat exchanger has its own working principle compared to other types of heat exchangers available in the market. The surface area of its wall, which separates the two fluids, is maximized, simultaneously minimizing the flow resistance of the medium. Channels are formed between the plates, and the corner ports are arranged so that the two fluids will flow through alternate channels. The cool fluid flows in an upward direction, and the fluid to be cooled overflows in a downward direction, thus transferring heat through the plates for highest possible efficiency. After completing this process, the heating medium is eventually cooled, and the cooling medium is toast. The heat transfer principle and design of the welded plate heat exchangers are characterized by their compact design, low heat loss, wide range of operations, high heat transfer effectiveness, small installation, and drawing function. Welded plate heat exchangers are commonly used in heavy and complicated zones as they do allow for much higher pressure and temperature fluids to be used. For example, in thermal power plants, it is employed to minimize the input energy to make hot steam, which is a prominent actor that drives the generator, and maximize the output energy in the form of useful electricity it produces. However, it doesn't work well with apparatus that requires a very high temperature difference between fluids, like temperature loop heat pipes, cryogenics industry, and so on. Hence, a welded plate heat exchanger is in fact provides high value for overall heat transfer in the system, creates a compact design, efficiently controls the temperature, and is considerably easy to clean and maintain.
I will now discuss the operating principle behind the welded plate heat exchanger, how it works and functions, and its main differences from the other heat exchangers. So first, its main differences from other heat exchangers. Its most observable difference is that it uses a series of plates instead of coils and tubes. In most designs, parang nakasandwich yung mga plates between the two metal covers. Marami rin naman mga design na parang isang rectangular prism siya or parang rectangular cube. Parang isang block lang siya, gaya ng nasa slide. Next difference is compact yung pagkakadesign sa kanila. So, mas favorable gamitin yung welded plate heat exchanger sa mga workplace na maliit lang yung available workspace. Next one is having a large surface area for heat transfer. Since plate nga ang ginagamit, mas malaki ang surface area na nagko-conduct ng heat kumpara sa mga coils and tubes. Next one is, since naka-weld yung mga planes sa isa't isa, mas matibay yung pagkakasin nila. Mas maliit yung chance na magli-leak yung working fluids. Kaya naman pwede gumamit ng mga hazardous chemicals without the risk na nagmi-mix yung dalawang fluids. Next, since naka-weld nga siya and matibay yung pagkakadikit between the plates, mas mataas yung kaya nitong i-handle na pressure at temperature. Because of that, pwede pang mas maging efficient ang heat exchange. Last one is lower fouling tendency. Fouling is the formation of unwanted deposit materials sa mga surfaces ng heat exchangers or sa case na to ay yung mismo mga plates. Ito ay dahil mas madaling linisin ang welded plate heat exchanger similar sa gasket plate heat exchanger na nadi-disassemble and mas madaling linisin. Mga methods for cleaning welded plate heat exchanger ay chemical cleaning, high pressure water jet cleaning, o kaya ay ultrasonic cleaning. Gaya nga ng sinabi ko kanina, usually ang welded plate heat exchanger ay composed ng dalawang makapal na metal covers and between them ay series of plates na usually ay gawa sa stainless steel. Isa pa, kung ang heat exchanger ay yung parang gantong style, tinatawag na front and back cover yung dalawang metal covers. And nasa front cover usually yung mga inlets at outlets. Sa ibang design naman, hindi lang sa iisang side yung mga outlets at inlets, gaya ng kanina. Same lang naman yun. Ang kailangan lang ay hindi makatapat horizontally yung inlet at outlet ng same fluid para magkaroon ng counterflow. Later on ay i-discuss ko pa yung counterflow. Yung mga plates naman, kung mapapansin nyo ay may mga engraving patterns or tinatawag na corrugations. Itong mga corrugations na to ang magdadirect ng fluid flow. Additionally, ang mga corrugations na to ay magkakos ng turbulent flow na isang dahilan for increased heat transfer. Turbulent flow is when the fluid flow is chaotic and disturbs one another. Basically, kapag tinignan mo yung movement ng particle na isang fluid, gulo-gulo at para bang random yung movement nila. Hindi siya parallel na parang diretso lang yung flow. As mentioned before, naka-weld yung mga plates pero usually sa gilid lang sila naka-weld. Because of that, magkakaroon ng mga maninipis na channel sa mga pagitan nila. Mga maliliit na spaces between the plates. Yung thin channel na yan ay essential para magkaroon ng magandang thermal conduction. Lastly, kung mapapansin nyo sa may bandang kanan, yung mga plates ay may holes sa apat na corners. Pag pinagpatong-patong yung mga plates, makakabuo ito ng parang pipe-like feature. Ito yung nagsisilbing entrance and exit ng fluid sa heat exchanger. Depende sa orientation ng plate at sa pagkaka-weld nito, yung isang fluid lang ang pwede mag-flow dito. Sa next channel naman ay yung isang fluid naman ang pwede lang mag-flow dito. Basically, alternate yung fluid na magpo-flow sa mga channel. So, fluid 1, fluid 2, fluid 1, and so on. Kung mapapansin mula sa illustration ay walang fluid flow sa first plate. Yan din yung case sa may bandang tulong plate. Walang fluid flow sa likod ng plate na yon. Ang tawag sa dalawa na yan ay start at end plate. The reason ko bakit walang flow dyan ay para hindi magkaroon ng heat exchange sa mga metal covers. So bakit? Una, di siya efficient dahil wala rin namang nagpo-flow na fluid sa kabilang side ng metal cover na yon. And another reason ay hindi naman talaga nakadesign yung thick metal covers na yon for heat exchange. Since alternating nga yung fluids na nagpo-flow kada plates, pwede rin nating masabi na may alternating cold and hot channel. Sa hot channel papasok yung warm fluid, sa cold channel papasok yung cold fluid. At between the two different fluids ay may plate, di ba? So doon na nga mismo mangyayari yung heat exchange. Magta-transfer yung heat from the hot channel papunta doon sa cold channel via conduction on the plates. And as a result, yung warm fluid ay lalabas na mas malapig and yung colder fluid ay lalabas na mas mainit. Lastly, yung welded plate heat exchangers ay nakadesign na counterflow. Meaning na opposite yung direction ng flow ng dalawang fluids. Nakita naman sa mga previous illustrations. Based sa graph na nandito, magkakaroon ng uniform temperature difference between the two fluids. Dahil dito, minimize yung thermal stress na nararanasan ng heat exchanger. Another advantage of counterflow is pwedeng umabot yung outlet temperature ng colder fluid kalapit doon sa outlet temperature ng warmer fluid. Basically, mas efficient yung heat transfer. Pero in theory lang yung nagiging almost equal yung both outlet temperatures ng dalawang fluids. At mahirap na yun ma-achieve sa mismong field na. And lastly, mas efficient yung counterflow dahil mas mataas yung LMTD niya kumpara sa parallel flow, and later on ay di-discuss pa yung LMTD or yung logarithmic mean temperature difference.
Next is for the classifications. So, this section will provide an overview of classifications of welded plate heat exchangers and their various features. So, according to news article of Plate Heat Exchanger Gaskets 2019, the welded plate heat exchanger is further divided into semi-welded, fully welded, plate shell, and brace plate heat exchanger. So, each one of them has a unique features and functions that will be discussed in this part of this paper. So, first is the semi-welded plate heat exchangers. These are combination of welded and gasket plates, making them an ideal choice for applications that require the handling of relatively corrosive media. So, these heat exchangers are configured by assembling two heat transfer plates that are welded together by laser welding. The only gaskets in contact with the medium are the two circular porthole gaskets between the welded plate pairs, which are available in highly resistant elastomer and non-elastomer materials. So, this design allows the semi-welded PHEs to withstand pressures up to 30 bars. This makes them suitable for evaporation and condensation in refrigeration and air conditioning systems, as well for ammonia fluid. Additionally, the relatively low chance of fluid loss makes semi-welded plate heat exchangers ideal for moving heavy materials. Next is the fully welded plate heat exchangers. So, these are advanced type of plate heat exchanger that are constructed from a series of corrugated metal plates welded together using laser or argon arc welding. This eliminates the need for gaskets, allowing the fully welded plate heat exchangers withstand high temperatures and high pressures than the traditional gasketed plate heat exchangers. So, the fully welded plate heat exchangers are ideal for applications that require extreme working conditions such as high temperature and high pressure, and are commonly used in thermal processes such as the superheating in heat recovery systems, refrigeration interchangers, and heaters of organic chemicals such as solvents, vegetable oils, steam, and batch reactors. So, fully welded can withstand temperatures up to 1000 degrees Celsius and pressures up to 40 bar. and are also capable of handling highly aggressive or corrosive fluids. However, the number of plates in the fully welded plate heat exchangers cannot be adjusted to meet the varying heat load requirements, and they can only be cleaned using chemicals cleaning methods. Next is the brace plate heat exchangers. So, these are evolution of detachable heat exchanger with the sealing material changed from a rubber pad to copper. And all the plates are welded or bonded together by a couple solder. So this ensures a tight fit of all contact points, resulting in high heat exchange efficiency and the ability to withstand pressure, thus achieving a long service life. So the copper brace plate heat exchanger is similar to the fully welded PHE. So same sila na with no gasket and suitable for high temperature and high pressure work conditions. Pero katulad ng fully welded, it cannot be repaired or cleaned easily. So yung difference nila is yung fully welded PHEs is formed by argon arc welding while yung brace PHE is formed by high temperature fusion welding of copper foil. So yung volume of copper brace plate heat exchanger is usually smaller than the fully welded, making it a great energy saving product with added advantage of being able to handle small temperature differences. So yung brace PHE is typically made of copper or nickel with working pressure up to maximum of 30 bar in copper brace and with nickel brace with maximum of 10 bar. And this is suitable for use with all refrigerants except sa ammonia. Pero for ammonia, yung brace plate heat exchanger can be used stronger metal alloys and laser welded channels alternating with those with a gasket. So, lastly, brace PHEs is incredibly efficient and reliable heat exchanger that is constructed using a special vacuum furnace bracing technology. So, making it more economical in the long run. Lastly is yung plate shell heat exchanger. So, it is a type of fully welded heat exchanger that combines the best characteristics ng shell and tube heat exchanger and ng plate heat exchanger. So, this involved inserting a fully welded plate pack into the shell, which distributes and eliminates the need for gaskets. So, itong heat exchanger na to was designed and manufactured to meet the specific needs of the customer that can withstand temperatures up to 400 degrees and pressures up to 150 bar, and works with liquid, gases, and the transitional phases between the two. So, it is welded together by a laser or automatic plasma. So, it combines the benefits of plate and tube heat exchanger, making it more widely used in the heat exchange industry. So, welded plate and shell heat exchangers are ideal for condensation and steam heating application. The heat exchanger's fully welded plate pack makes them suitable for handling aggressive media as well as high temperatures and pressures. Furthermore, they are much lighter in weight and take up less space than shell and tube heat exchanger, making them an excellent replacement option. So, that's all for the classifications of welded plate heat exchanger.
Good day. My name is Carlo Feliciano Ipasna, and I'm going to discuss the design and the operation. In this part, the illustration and the corresponding parts of a welded plate heat exchanger are going to be discussed, as well as its physical and thermal design parameters. First, welded plate heat exchangers are manufactured by welding the heat transfer plates in both the hot and cold fluid streams of the equipment, which significantly reduces the cost of welding the entire plate, according from API 2010. The plates on a welded plate heat exchanger are basically welded on both the hot and cold fluid stream, or the pathway of the fluid coming in and out of the plate heat exchanger, both hot and cold. Also, the gaskets on these plates are non-existent because the plates itself are already welded. This then results to a much lower or lesser cost of the entire plate or the overall equipment. Next, the welded plate heat exchangers design favors using corrosive fluid streams as either the hot or cold fluid media considering the corrosive fluid cannot damage the welded corrugated metal plates that are used as the heat transfer media in this instance. based from UWE 2011. So the plates on a welded plate heat exchanger are basically made up of strong metals against any other fluid or almost any type of fluid, and are also very high resistant to corrosion or rusting. So these metals include stainless steel, nickel, titanium, carbon steel, and many more. Also, the corrugated metal pattern on the welded plates significantly reduces the accumulation of deposits in the plates itself. So this then result to a lesser probability of corrosion and or rusting. Moreover, uh, the primary type of welding used in this welded plate heat exchanger is the laser welding or argon arc welding. Next, these are tightly closed packed plate heat exchangers that are very durable and are gasket free between the series of plates. Again, the gaskets between the series of plates are non-existent anymore because the plates are welded and which significantly reduces the cost of the entire equipment. Also, this results to a much higher temperature and pressure resistance. So the welded plate heat exchanger can be used or operated on environments with very extreme conditions or settings that have very high temperature and pressure. In this slide consists the illustration and the corresponding parts of a four-sided detachable fully welded plate heat exchanger, also known as a compablock. So this is one of the most common welded plate heat exchanger, and as you can see, these are the basic or common parts of this welded plate heat exchanger. So these include top and bottom head, four side panels, welded heat transfer plate pack, column baffle, gasket, and support. So as you can see, this welded plate heat exchanger contains side panels and top and bottom head completely detachable. So meaning the welded heat transfer plate pack can be inspected or cleaned very easily and quickly by just loosening the side panel bolts as well as the bolts on the top and bottom head for an easy inspection and cleaning of the core or the interior. Basic parts of welded PHE. First one, welded heat transfer plate pack is made of a series of corrugated metal plates typically welded by using argon arc or laser welding. So these were the fluid, which are hot and cold flows, and also the heat transfer or heat exchange occurs. So it is one of the most important part of a welded PHE. So the plates that are used on this welded heat transfer plate pack are basically made of strong metals and highly resistant to corrosion or rusting. So these are stainless steel, carbon steel, nickel alloy, hastelloy, and titanium, and many more. So again, the gaskets on this plate pack are non-existent anymore because the plates are welded, and also the gaskets are just limiting the operating potential of most types of PHE or plate heat exchanger. So by having gaskets, the operating conditions are limited to up to 180 degrees Celsius in terms of temperature and up to 25 bar in terms of pressure. So by removing those gaskets entirely, the operating conditions of a welded PHE can exceed those limitations. So it can go beyond 180 degrees Celsius and above 25 bar. Next, top and bottom head and 4 side panels provide protection and outer covering for the welded plate pack. So these components are the outer covering and the protection of the welded PHE or the interior of the welded plate heat exchanger. So these components are basically made of steels as well and strong metals in order to protect the interior of the equipment. Also, the top and bottom head and the 4 side panels can be detached easily and quickly by just removing and loosening the bolts. So this is really helpful for quick inspection and cleaning of the interior and the cleaning of the welded heat transfer plate pack. Next, column is a vertical pillar that provides support between the top and bottom head, as well as the 4 side panels. So, from the word itself, column, it is a support that is upright or vertically. So, it provides the necessary support on the top and bottom head, and as well as the 4 side panels. So, it is really helpful for foundation and stability of the entire welded PHE. So for baffle, also known as a guide plate, is an important element of heat exchanger design. So it is important because it directs the flow or the pathway of the cold and hot fluid. So it is very important, and it also indirectly supports the heat transfer plate pack or the welded heat transfer plate pack because it is attached uh, across the welded heat transfer plate pack. Next, gasket acts as a lining or additional layer for sealing the inside surface of the welded plate heat exchanger so that the fluid contents going in and out will not leak accidentally. So the gaskets are basically the seal of the entire welded PHE. So it seals and provide a protection somehow on the 4 side panels in order for the fluids that are going in and out to not leak easily or leak accidentally. So it is really helpful to have gaskets underneath those side panels. Lastly, support serves as the base of the whole heat exchanger, keeping the device stable. So from the word itself, support, it is basically the very foundation of the overall welded PHE. It keeps the welded plate heat exchanger in stable position and in place. This table presents the design parameters of welded plate heat exchanger. First, plate material, stainless steel 304L, 316L, 904L. Alloy 254 SMO, Hastelloy 276, Duplex SS, titanium or nickel 200, 201. These are the specific names of the materials that are normally used in manufacturing the plates on a welded plate heat exchanger. These materials are very strong and highly resistant to corrosion and crevice. So the crevice are the openings or cracks that might occur on the plate surfaces. So because of its strength and rigidity, these materials are very helpful on welded plate heat exchanger, as it can survive against varying temperatures and pressures. But we should also take note that the plate material must be carefully selected based from the working fluids, the working conditions, and the temperature and pressures where the welded pH is going to be utilized. Because if not suitable, the plate material used can cause major problems and overall damage on the welded plates. Thus, it should be noted that the plate material must be carefully selected. Next, plate thickness. It can range from 0.5 millimeters to 1.2 millimeters. So when it comes to plate thickness, having too thin, it can cause the plate to be easily deformed. However, having too thick, the plate can decrease the heat transfer efficiency of the overall plate heat exchanger. So it is also dependent on a number of reasons or factors. This includes the working fluids or types of working fluids, as well as the working conditions and the temperatures and pressures. So when we have 1 megapascal pressure, the corresponding plate thickness is going to be 0.5 millimeters. And if having more than 1 megapascal, 0.6 millimeters and above should be used. When it comes to having too high temperature, 1.2 millimeters is going to be used. And while having lower temperature, less than 1.2 millimeters or above 0.5 millimeters is going to be utilized. And when it comes to fluids that have water, soda, and oil contents, 0.5 millimeters is normally used. However, having acids, strong alkalis, and corrosive mediums, 0.6 to 0.7 millimeters is acceptable. So those are the factors where the plate thickness varies. Next up is the plate element pattern. So corrugated element or corrugated pattern on the plates. So this has a lower substance contact points, which promotes more turbulent flow and prevents the accumulation of deposits on the plate surfaces. So these deposits can cause major fouling or rusting if left unchecked. But having corrugated pattern solves those potential problems. Next, plate structure, welded heat pack. So again, welded heat pack, there are no more gaskets in between the series of plates. Number of plates, so it can be up to 2,500. Surface area, 0.6 to 600 square meters. So it depends on the manufacturer and the working condition and setting where the welded plate heat exchanger is going to be used. So it can again range from 0.6 to 600 square meter. When it comes to weight, 250 kilogram to 60 tons. So it also depends on the size or the area of the welded PHE. So there are compact ones and also large to very massive welded plate heat exchanger. So the design temperature can range from negative 196 degrees Celsius to 400 degrees Celsius. So it is according to Hoffman exchanger or HFM industry. So it is varying from negative 196 to 400 degrees Celsius, but it also depends on the manufacturers of welded plate heat exchanger. Some heat exchanger can be utilized up to 350 degrees Celsius, 380 degrees Celsius, and so on. Next one, design pressure. So vacuum to 40 bar. Vacuum to 40 bar. So it can be utilized up to 40 bar or 4,000 kilopascal. It also depends on the manufacturers of the welded plate heat exchanger. So some would say their welded PHE can be up to 30 bar, 35 bar, and so on. So it is highly dependent on the manufacturer. This is the second part of the table for the design parameters of a welded plate heat exchanger. For continuation, The connection size, it can range from 50 millimeters to 600 millimeters. So this specific parameter is highly dependent on the manufacturer or companies that create the welded plate heat exchangers. Next, heat transfer area. It can be up to 700 square meter per unit. So the heat transfer area is mainly dependent on the number of plates that are used on a welded PHE as well as the size of those plates. And shape, it is rectangular or block. So the shape of a typical welded PHE resembles a block or rectangular in shape. But there are some welded PHEs that are cylindrical in shape. Next, main structure is a compa block, which are two-side or four-side detachable. So the major structure or one of the main structures of a welded PHE is a compa block, which are rectangular block in shape, and also it can be detached using loosening or removing the side panel bolts. So there are two types. So two side can be detached, and another type is a four-side detachable. Four-side panels can be detached. Next up is mass flow rate. So according to Alpha Laval, it is one of the popular manufacturers of a plate heat exchanger. So according to them, the mass flow rate are normally ranges between 0.05 kilogram per second to 1,400 kilogram per second. For pressure drop, it ranges from 20 kilopascal to 100 kilopascal. So for pressure drop, it depends on the size of the overall welded PHE. So for the allowable pressure drop to increase, the size of the overall plate heat exchanger must be decreased. And in another way, if the allowable pressure is to be decreased, the size of the overall PHE should be increased. So it is indirectly or inversely proportional to the size of the welded PHE. So last, for overall heat transfer coefficient, it ranges from 1,000 to 7,500 watt per square meter degree Celsius. So this parameter is typically denoted as small letter K or capital letter U. So this is a measurement based on the resistance to heat flow, which is according to the plate material, the type of working fluid, and the specific classification of the plate heat exchanger. This data presents the simulated plate heat exchanger parameters. So the data presented here are based from the study of Fargali and others in 2014, wherein one of their methodology includes a simulated plate heat exchanger. However, they did not specify the specific type of plate heat exchanger in this one, but we still use this table on our technical report because it contains the specific parameter and important variables that are helpful in the design and operation of a welded plate heat exchanger. So the parameters, symbol, and value are included in the table. So the parameters are inlet and outlet temperature of cold fluid, inlet and outlet temperature of hot fluid, as well as the heat capacity rate of both hot and cold fluids. So there is a corresponding symbol and value. For continuation, there are also minimum and maximum heat capacity rate with their corresponding symbol and values, as well as the heat capacity ratio, number of transfer units, effectiveness, log mean temperature difference or LMTD, overall heat transfer coefficient, and the area of heat exchanger. So these parameters are important in the design and operation, and also these parameters can be calculated and measured by using different formulas and equations, as well as simulation or simulating tools and softwares. Next, the values from these parameters can be solved through the use of numerous formulas, equations, and calculation methods solely for plate heat exchanger design. So there are no specific type of a plate heat exchanger, so the welded plate heat exchanger can be one of them. For example, like mean temperature difference or LMTD can be calculated by using the formula, which is LMTD is equal to quantity T1 minus T4 minus quantity T2 minus T3 all over ln quantity T1 minus T4 all over T2 minus T3, wherein the T1 is the inlet temperature of hot fluid, T2 is the outlet temperature of hot fluid, T3 the inlet temperature of cold fluid, and T4 is the outlet temperature of cold fluid. So these parameters are very helpful in the design and manufacturing of the plate heat exchanger in general. And finally, these parameters or the data presented here can be supporting data or supporting information for further innovation of plate heat exchangers.
So, before tayo mag-start from application, kailangan muna nating i-delve deeper. Ano ba ang ibig sabihin ng heat transfer? Ano ba yung purpose niya? Bakit ba siya ganito? Bakit siya ginagamit sa HVAC, sa refinery, sa chemical processing? Bakit hindi na lang heat sink or anything? I-explain ko ngayon before tayo mag-start ng application literally ng mga heat exchangers. So, ano nga ba yung heat exchangers? Yung heat exchangers kasi is siya yung device na ginagamit in order to transfer a thermal energy. It can be either hot temperature for hot process and as well as cold temperature for cold processes. Yung heat exchangers kasi is ginagamitan siya ng fluids, either liquid or gas. Since ang heat exchangers nga ay merong 4 holes na nagse-separate from hot fluids and cold fluids, we can describe na sa HVAC makikita natin, 'di ba meron tayong yung 3 modes of heat transfer. Yung heat transfer is yung conduction, yung convection, and radiation. Ang common kasi sa mga heat exchangers is yung conduction and convection. Since sila yung mas efficient gamitin in a way na pag ginamit mo sila is mas mapapakinabangan siya ng mga machine and mas cost effective kumbaga. Tapos, mag-start na tayo ngayon ng heat exchangers talaga. So, ang topic namin ni Hilson Cruz is welded plate heat exchangers for petrochemical industry, chemical processing, as well as yung condenser ng HVAC or air conditioning and refrigeration system. So, explain ko muna ano nga ba yung welded plate heat exchangers for petrochemical industry. Saan nga ba siya ginagamit? Makikita nyo naman sa device na nasa taas, yung pinakataas, meron doon na cold and yung kulay blue and kulay red na image kung saan pumapasok, saan lumalabas. Cold means cold temperature or low temperature, while yung red is yung high temperature or yung mas mainit. So, saan ginagamit tong welded plate heat exchangers na to? Ginagamit nga yan sa petrochemical industry, such as yung refinery, hiniheat nila yung crude oil, pinipreheat. Diba sabi ko nga kanina, yung heat exchangers, it's either from cold temperature, then yung hot temperature. Kasi nga 'di ba ang principle ng heat transfer ay ang principles for energy to flow is meron tayong temperature difference. Like for high temperature pupunta siya sa low temperature kasi 'di ba? 'Yun naman talaga ang idea ng heat transfer. As well as ginagamit din siya sa natural gas, refined oil and cook oven plants. Next naman is ire-report ni Hilson yung dalawa, yung chemical processing and as well as yung condenser sa HVAC.
Another application pa ng welded plate heat exchanger ay sa chemical processing. For example is yung sa food, biological and biodegradable material preservation, at saka sa marami pang iba. Yung heat exchanger kasi, it is one of the most important and widely used pieces of process equipment sa chemical process industries. So, there's always the need to control the temperature of corrosive liquids or to condense yung mga corrosive gases as part of the chemical process. Sa chemical plant naman, heat exchangers are often used for heat recovery purposes to exhaust hot gas. Yung welded plate heat exchangers talaga yung ginagamit dito kasi they were discovered to be capable and high performance, gaya ng sabi namin kanina. High performance alternative siya compared sa traditional heat exchangers na tube fin type. Lastly, application of welded plate heat exchanger ay sa condenser ng air conditioning and refrigeration system. So, when we say air conditioning, ito yung meron tayong coolant na built-in sa system. Yung function nito is to remove heat and moisture sa isang specific area. Whereas in refrigeration naman, it is designed to cool an immediate area. So, sa refrigeration, gumagamit tayo ng pipes na may coolant to force a liquid into a gas and para magkaroon tayo ng cooling effect. So, in other words, yung refrigeration, it keeps the cold air close, samantalang in air conditioning, it pushes it away. So, and sa mga processes ng systems na ito ay gumagamit tayo ng heat exchanger. So, specifically, yung welded plate heat exchanger yung ginagamit natin, which is matatagpuan sa condenser. And yung main function kasi ng condenser is either release or mag-collect ng heat. At isa talaga to sa mga ginagamitan ng welded plate heat exchanger.
So, yon, good day. Tumungo naman tayo sa advantages and disadvantages of using welded plate heat exchangers. First, advantages muna tayo. Number 1, spatial friendly. It is commonly known that the more powerful means less in size. So, para mas maintindihan natin, i-compare natin siya sa daily life things. For example, yung hard drive. Alam ko yung hard drive noon, nung year 1956, sobrang laki niya. Almost kasing laki siya ng cabinet. At kung gusto mo siyang i-move o i-deliver, kailangan mo pa siyang i-shift via truck. At hindi lang yun. Alam ko yung capacity lang nun is 15 MB, which is compared sa hard drive ngayon, ganito na lang siya kalaki. Parang one finger na lang yung laki niya. Yung iba nga mas maliit pa dyan . At hindi lang yun. Ang capacity ng hard drive today is umaabot ng 128 GB and above. So, isipin nyo yun. Dun pa lang. Hard drive noong 1956 from hard drive today. Dun pa lang makikita na mas maliit, mas powerful or mas malaki yung storage. Alright, next. By lessening the spatial in electrical cabinets can prevent the risk of heat pockets. Which is, totoo naman, di ba? The smaller, the compacted, the more sturdier. Compared to the bigger, the less compacted, the less sturdier. So, yan. Number 2, easy plate cleaning. Since welded plates are detachables, cleaning and maintenance are easy for the components. So, yan. Sabi lang daw, yung mga plates na nakasiksik, madali lang daw siyang tanggalin. So, pag tinanggal mo, linisin mo, tapos kabit mo ulit. Kumbaga, ang point dito, hindi siya naka-fix sa machine na kailangan mo pang disassemble lahat para lang makuha yung plates at linisin. Yung plate mismo, pwede mo siyang tanggalin at linisin individually. Number 3, maintenance is simple. Due to the fact that the welded plate heat exchanger doesn't need any external components, they don't need to be frequently maintenance. Or in other words, hindi need ng frequent maintenance o hindi mo siya kailangan linisin kada buwan o kada linggo, which is very good para mas makasave ng maintenance costs. Next, number 4, stronger than gaskets. It is far more suited on withstanding chemicals and high temperatures that could damage its components. So ito comparison to sa gasket plate heat exchangers. Ang sabi lang naman dito is ang welded plate heat exchanger ay mas matibay, mas matatag, at mas malakas kumpara sa gasket. So yun. Lastly, efficient flow. Welded plate heat exchangers are designed for optimized and efficient plate design compared to gaskets. So iyon, comparison ulit. Sinabi lang naman dito is mas maganda yung agos o yung daloy ng fluids from using welded plate heat exchangers compared on using gasket plate heat exchangers. So yes. Ngayon, tumungo na tayo sa disadvantages of using welded plate heat exchangers. All right, number 1, high initial cost. The plates are made out of titanium, so it's not a surprise. It is very expensive. So, yun. Since gawa siya sa titanium, mahal siya, which is a metal. And a very rare metal na hindi mo agad siya makikita sa market. Hindi siya common sa market. Siguro kung gawa lang siya sa plastic o kaya naman sa aluminum steel, baka mas makamura ka. Pero since it's made out of titanium, mahal talaga. Next, corrosion effect. Since the plates are made out of titanium, which is a noble metal, its parts are prone to corrosion in the cooling system. So yun nga, since gawa siya sa metal, a noble metal, meron siyang capabilities na mag-rust o mag-corrosion effect. Especially kung dadaan siya sa heat or hot temperature to cold temperature. Ayun yung main reason kung bakit nag-i-start ng corrosion or rusting effect. Number 3, hard to find leaks. The pressure tests are not that simple to do compared to tube coolers. So finding leakage are very difficult. So yun. The reason behind this is its compact design. So syempre, pag mas compact, mahirap talaga makahanap ng leakage yan, especially kung sobrang liit lang. Ang point dito is, kung makakita ka ng leakage, kailangan mo pang i-disassemble yung buong machine para lang makita yung small leakage na yun, kung saan siya nanggagaling. Next, fluids must be very clean. Finding a contaminated fluid inside the heat exchanger is a very big problem, mainly because of the machine's compact design. So yun, compact design na naman ang reason behind the disadvantage. So parang sinuport niya lang yung disadvantage number 3 na pag merong pumasok doon na kung gaano man kalit o kalaki yan, mahirap na siya matanggal kasi nga compact yung design siksik. Hindi mo siya agad-agad mabubuklat. Kung malaki sana pwede, kaso compact siya tsaka small. So yun yung point doon. And lastly, limitations. It is limited to take thermal stresses due to its inability to expand because of its compacted designs. So, ayun nga, compact design ulit. Dahil maliit lang siya, maliit lang din yung kaya niyang i-take na stress. Kung di ako nagkakamali, generally, 15 MPa lang yung kaya niyang i-handle na stress. At hindi niya kayang pataasin yun or palakahin para umabot ng 20 MPa, 25, 50. Kasi nga, maliit lang siya, tsaka siksik. Siguro kung malaki yung heat exchanger, pwede. Pero, from welded plate heat exchanger, hindi. Hanggang 15 MPa lang. So, yun. Thank you once again. These are the 5 most common advantages and disadvantages of using welded plate heat exchangers.
For the last part, conclusion and insights. So first, habang nagre-research kami about the type of heat exchangers and kung ano yung difference niya ng welded plate heat exchangers sa ibang mga type, and yung mga pros and cons niya for comparison, napansin namin na wala talagang masasabing perfect na heat exchanger. Kasi, depende talaga yun kung ano yung best option sa paggagamitan ng bawat heat exchanger. Tulad ng welded plate, yung mga diniscuss kanina nila Prince and Hilson na mga applications niya, doon best nagpe-perform yung welded plate heat exchanger. Pero kung kunwari, sa ibang system na siya ginamit, kunwari, ginamit na siya sa ibang mga systems, medyo hindi siya magiging efficient or baka hindi siya talaga magiging fit. So, depende talaga sa paggagamitan niya at the end of the day. And then, next is, syempre, sa mga future researchers or mga future students, mechanical engineering students, na nagbabalak na mag-dive deep sa concept ng mga heat exchangers or particularly sa welded plate heat exchangers para makakuha sila ng knowledge about the topic. We as a group, confident kami na makakatulong itong tech report na to para matulungan or ma-aid yung mga future students sa heat transfer subject nila. Kasi sobrang detailed talaga yung tech report namin para, alam mo yun, kumbaga package na siya. Dito na lahat. Yeah. Detailed talaga siya. Then, lastly, also, as a leader and a representative of our group, gusto lang namin sabihin na sobrang natuto talaga kami about heat exchangers and kung gaano siya ka-importante sa engineering systems and sa daily life na din natin. And alam ko mataas yung confidence namin na magagamit namin itong mga nakuha naming knowledge pagdating ng panahon na na-apply na namin to sa future careers namin as mechanical engineers. And that's the end of our presentation. Again, we are Group E. Thank you, Ma'am Madi, and thank you everyone for listening.